Hello viewers, welcome back to my channel. Today's topic of discussion is on introduction to deadlocks and the necessary conditions for a deadlock to occur in the system. So from this session onwards, I shall be discussing topics on another module in operating systems, and the module title is deadlocks. Let me start with the introduction for the deadlocks in this session, and then I can move on to the further topics in this particular module. So the very first thing you should know is about the definition. Now, before I start reading out the definition, that is the formal definition given in the textbook, let me just tell you first in very simpler words a particular situation or scenario in the system. So what is the situation or what is the scenario in the system is, see, now we are all aware that operating system consists of what? All the processes that are getting executed. And also these processes, they require what? They require the different resources to perform their task. Now let us suppose there is one process, okay, P1. This process P1 is actually assigned with one resource R1, fine. There is another resource called R2, which the process P1 is interested in getting that. So I have to show the arrow direction. Now these notations I'll be telling you in my future session. Presently you just remember that the process is indicated with the notation circle and the resource is with a square. And also the direction of the arrow indicates that the resource is assigned to the process. And if the direction is towards this particular resource, it indicates that the process is interested or making a request for this resource. And there is another process called as P2, fine. P2 is assigned with resource R2. You can see the direction of the arrow. The resource R2 is assigned to process P2, but P2 is interested in what? Also getting one more resource, and that is P1. So P2 is getting another resource called as P1. Now look here, what is happening is, so now time being, just forget about the diagram. There is a process P1. P1 wants R1 and R2 to complete the job. P2 is another process. P2 wants R1 and R2. Fine. So this is what is the present situation in the system. There are two processes, and these two processes needs two resources. R1 is one resource, R2 is another resource. So this R1 and R2, when I say resource can be anything, like it can be a printer, scanner, plotter, CPU, memory. So that's the reason I have mentioned here any kind of resource, either it can be in hardware or software. Now here we are talking about, in general, the word resource. It can be anything in the system. Without using the resources, the process will never be able to complete the job. But how many resources the process requires is the question. So this diagram indicates that the process P1 is interested in R1 and R2, and process P2 is also interested in R1 and R2. But what has happened is, initially these processes were assigned only with one resource. So you can see here process P1 is assigned with resource R1. So P1 got R1, but P1 has not got R2. R2 is given to P2. So P2 has not got R1. So this way, now P1 is not able to complete the job, nor P2 is able to complete its job. The reason is, until they get the other resource, then only they'll be able to complete the job. So now both are what? Both are stuck here. Both are not able to proceed. We say there is no progress happening in the system, and this is what is called as deadlock. A process is not able to perform its task because the resources which that process wants is held by another resource. And that is what is the definition. Now I think it will be more clear if you read the definition. A set of processes is deadlocked if each process in the set is waiting for an event that only another process in the system or in the set can cause. So here the set is what? P1 and P2. These are the two processes in the set. A set of processes is deadlocked. These two processes are deadlocked if each process in the set is waiting for an event that only another process in the set can cause. Definitely it is true. P1 is waiting for P2 to release the resource R2, whereas P2 is waiting for the process P1 to release the resource R1, but neither of them are releasing the resources. So that's the reason we say there is a deadlock here. There is no progress happening. And if you try to recall the word starvation, which you have learnt in the process management, there you could have seen that the processes are starved also. We have used the word as starvation or the processes getting starved. Now the difference between starvation and deadlock you should know here. Deadlock is an infinite wait, whereas starvation is a finite wait. So in starvation, if you see in process scheduling, few processes were getting scheduled, like higher priority processes were getting scheduled, whereas lower priority processes were in the queue. But lower priority process may wait for some time, maybe some milliseconds, minutes, hours, but definitely later their turn will come and they'll be able to perform the job. But during that time, we say the processes were starved. That means there is a starvation in the system, but it is not infinite. The processes will definitely get their turn and they will complete their jobs. In deadlock, the processes are not able to complete their job because each one is waiting for the other process to release the resource, and that is never happening. So this situation is called as deadlock. And it is not just with case of one resource, it can be with any number of processes and with any number of resources. If you want, I can show you one more diagram wherein you can see P1 is waiting for what? P1 is assigned with resource R1, but P1 wants one more resource, so it is making a request for R2. But R2 is already assigned to P2. P2 is making a request for R3. Okay, P2 is making a request for R3, but R3 is already assigned to P3. Then P3 is making a request for R1. R1 is already assigned to P1. So this is where we say that a deadlock is happening. Now you see all these three processes are completely not progressing towards their job. All these three processes are not able to complete their job. So this is what is called as the deadlock in the system. But remember here, for the deadlock to happen, there are four necessary conditions. Which are those conditions? First one is the mutual exclusion, the other one is hold and wait condition, no preemption condition, and circular wait condition. Unless these four conditions occur in the system, only then we say deadlock can occur in the system. So that's why I have written here one note also. You can always remember, this is very important point. Note, all four of these conditions must be present for a deadlock to occur. If one of them is absent, no deadlock is possible. If you see the first condition, mutual exclusion, you people are quite familiar now. What does mutual exclusion says? That the resource is not shareable. Resource is not shareable. If mutual exclusion is there in the system, then definitely there is a chance of having a deadlock, because in the previous diagram I have shown you P1 is what? P1 is assigned with a resource R1, fine. P1 is requesting for another resource R2, but R2 is assigned to P2. R2 is assigned to P2 and P2 is making a request for R1. So why these processes are not able to complete their job is because resource R1 is not shareable, resource R2 is not shareable. Both these processes cannot use the resource at the same time. Only the resource can be used by single process at a time. That's the reason we say mutual exclusion is one condition, one of the four conditions wherein it will lead to deadlock. Similar way, you can always take one example. Suppose there are two persons. Let me take one name is Amit and another person is Ritu. Amit wants the scale and pencil both to complete some drawing, okay, or some sketch. Amit is in need of these two items, scale and pencil. Ritu also needs scale and pencil. Now assume that there is only one scale present and one pencil present, okay. Now how is that both of them will be able to do the job? What has happened is the moment the sketch program or sketch competition starts, Amit got the scale and Ritu got the pen. So Ritu is assigned with pen and Amit is getting the scale. But Amit also wants what? Pen to complete the job, and Ritu wants what? Ritu wants scale to complete the job. Now neither Ritu is releasing the pen or pencil, nor Amit is releasing the scale. Then both of these are not able to carry out their job. We say there is a deadlock here. Now Amit is waiting that Ritu will release the pencil so that he will complete the job, whereas Ritu is waiting that Amit will release the scale so that she will complete the job. But neither of them are releasing the object here, item here. We say in operating system as resource. So here we say that this scale and pencil are the resources, Amit and Ritu are the two processes. So there is only one scale, means one instance of the resource is available in the system and one instance of the pencil is available in the system. That's the reason both are held here. They are not able to proceed towards their, these two are not able to complete their job. So this is just a example I am telling. Now this is what and why we say, see, even you can take the same example for the mutual exclusion. Scale is not shareable, pencil is also not shareable. Have you seen two people using the scale at the same time to complete their job? Not possible. Have you seen two people using one single pencil to complete their respective jobs? Not possible. So we say scale is non-shareable, pencil is also non-shareable. So we say there is a mutual exclusion here. Only one person can use the resource at a time, the item at a time. So that is why we say this is one of the condition that leads to what? Deadlock. The second condition is hold and wait condition. If the system is exhibiting hold and wait, then definitely there is a chance of deadlock occurring in the system. Amit is holding the scale, fine, waiting for the pencil. Ritu is holding the scale. Ritu is holding the pencil but waiting for the scale. So hold and wait. One process is holding one resource, waiting for the other resource. Why this has happened is, initially this process P1 was assigned R1, okay, process P2 was assigned with R2. Later P1 wanted to complete the job, R2 also, and later P2 also wanted R1 to complete its job. So this is what later, if the processes are making a request for resources, then it will lead to this type of condition called as hold and wait condition. So this is what is an example here. No preemption condition. What do you mean by no preemption? So second condition also I have explained here, hold and wait. The third condition is what? No preemption. So here no preemption is what? If a resource R1 is assigned to P1, then you are not going to take away the resources from that process P1. If resource R2 is assigned to P2, you are not going to take away the resource R2 from P2. So that's what in shorter sense, one simpler words I have written here, cannot be taken away forcibly. Now Amit cannot force Ritu to release this pencil, nor Ritu can force Amit to release the scale. So this is what is called as no preemption. Forcibly the resources cannot be taken away from the from the processes. Definitely if this is the case, if you are not forcibly taking away the resources, then once again the processes will not be able to proceed also, and that will lead to deadlock. That is one of the condition. Fourth condition is circular wait. So what does circular wait means? Circular wait is the process is waiting for the next process in the chain to release the resource. P1 is what? Waiting for R2. R2 is actually assigned to P2. P2 is waiting for R1. So if at all I have to remove these resources, in other words, if I have to remove resources and write only processes in the diagram, I can say that P1 is waiting for P2, okay, and P2 is waiting for P1. Why they are waiting for each other is, P1 wants P2 to release R2, P2 wants P1 to release R1. So I am not showing the resources here, just see. So this can be a chain also like this, not only just with two processes, you can take 3 processes, you can take 4 processes, any number of processes to show this circular wait. P1 is waiting for P2, P2 is waiting for P3 to complete its job, P3 is waiting for P4, P4 is waiting for P1 again. So this is what is in a circular fashion. So we say it is a circular wait. Why? These are the 4 conditions for the deadlock. All 4 of these conditions must be present for a deadlock to occur. If one of them absent, no deadlock is possible. So this is all about the introduction to deadlocks and the 4 necessary conditions for the deadlock. Hope this session is useful to you all. If you find this session useful, please like, share and subscribe to my channel. Thank you. Bye bye. Take care.